Welcome to section 5.4. This section is all about indirect proofs. Up to this point, we've been doing proofs directly. Now we're going to do indirectly, which basically shows something is true by showing that all the alternatives are false. It's kind of like going through a back door type thing. It's a little bit different, so we're going to spend a couple days going over this. I've divided the section into 2 days, and so we'll get started right away. To help us get into the mode of doing this, I want to review what we did when we were going through logic in chapter 2. And we talked about conditional statements, their converses, their inverses, and their contrapositives. And we found out that the conditional and the contrapositives had the same truth value every time. They always had the same truth value. So I kind of want to go back to that just to help you review. If you remembered it contrapositive, we would take the original conditional, and first its converse would be to switch the if and the then. The contrapositive would take the converse and negate both terms. So, in order to write the contrapositive of an if-then statement, you have to switch the if and then and negate both. So let's review that. Here's a conditional statement. If two intersecting lines form right angles, then they are perpendicular. That's our original statement. What would the contrapositive be? So take a minute, see if you can remember what that was. Switch the if and the then, make them both opposites, negate both, see what you come up with, and then see if it matches mine. Okay, here's what I came up with. I switched them and I started with if two intersecting lines are not perpendicular, then they do not form right angles. Notice I switched them and made both of them negative, or the opposites. Is this true? If two intersecting lines are not perpendicular, then they do not form right angles? Yeah, both of these statements are true. Let's do another simpler conditional. If x equals 5, then x plus 2 equals 7. What would be the contrapositive? Pause if you need to, think it through, come back, and then see if it matches what I wrote. Okay, here's the contrapositive. I switched them and I negated both statements. If x plus 2 does not equal 7, then x does not equal 5. Let's try one more. Okay, here's the statement. Hopefully this is getting easier for you. Here's my conditional. If y is greater than 10, then y squared is greater than 100. What is the contrapositive? Okay, I hope that you got if we're negating y squared is greater than 100. If it's not greater than, then it's less than or equal to. So that's how I negated that. If y squared is less than or equal to 100, then y is less than or equal to 10. Switched them, negated both. Notice both statements are true. They are equivalent. Okay, so that was just a kind of a warm-up. That's sort of like a bell ringer for this lesson. Now we're going to get into the heart of it. Here is my first statement. Again, what is the contrapositive of this, and what is the truth value of both? Now, I really do want you to take the time to make this video worth it. Pause it, write it out. It makes such a difference. And then restart it and check your answer with me. Okay, so here is the contrapositive of my statement. If two angles in a triangle are not congruent, then the opposite sides are not congruent. This started with the sides, went to the angles, switched it, made it not. Now, were they true? If two sides in a triangle are congruent, then are the opposite angles congruent? Yes, that's true. If two angles in a triangle are not congruent, then does that mean the opposite sides are not congruent? Yes, it does. Also true. How did you do? Next one, I know this may seem tedious, but it really, if we can do this, it'll make the next steps so much easier. So this next one, if a natural number is prime, then it is an odd number. What's the contrapositive? What's the truth value of both? Go for it. Pause and then come back. Okay, I hope you came up with that and you said, here's my contrapositive. I took this. If a natural number is not odd, then it is not prime, negating both. Now, what's the truth value of this? Because you might think, well, this is totally true. If a natural number is a prime number, then it's an odd number. It would have to be. Except for that pesky number 2. Number 2 is prime and it is even. Therefore, that original statement is false. So what about the second one? The second statement. If a natural number is not odd, then it is not prime. Again, 2 would be the counterexample because 2 is a natural number that is not odd and is prime. So, false and false. Last one, now we're getting to the heart of what we're dealing with in this statement. If a conditional is true, then its contrapositive is true. What is the contrapositive of that statement? And what is the truth value of both? Okay, here is my contrapositive. If a conditional's contrapositive is false, because not true would be false, then the conditional is false. What's the truth value of both of these? Remember we said the conditional and the contrapositive are equivalent statements. So therefore, if one's true, the other's true. If one's false, the other's false. Both of these statements are true, and this is the heart of what we're getting at. This is why we're taking the time to go through these, because we're going to use these kind of statements in an indirect proof. Okay, I've written down on the board some steps for an indirect proof. The first step is the most critical. Usually when you're trying to form a proof, you have the givens and then you have what you're trying to prove. So what you are going to do is you are going to temporarily assume that what you're trying to prove to be true is not true. That's what I mean by assume the opposite or the negation of the conclusion. What am I trying to prove? I'm trying to prove that all prime numbers are odd, let's say. Well, that's not a good one. I'm trying to prove that all angles in a triangle add up to be 180. That's what I'm trying to prove. The sum of the angles in a triangle are 180. So what I would assume is that the sum of the angles in a triangle do not equal 180. That's what I would temporarily assume. Then I would go through the steps, assuming that that's true, and I'd realize, wait a minute, there's a big contradiction. So that goes back because this has a contradiction, then it's obviously false, so what am I originally trying to prove must be true. Those are the statements. So first, temporarily assume the negation of what you're trying to prove, reason through that until you come up to a big contradiction that shows that that can't be true, so therefore the original statement must be true. If this is confusing you, let's walk through it a few times and you'll say, oh, okay, I see what you're saying now. Let's see if I can make some sense out of it. The reason indirect proofs work is because of the law of contradiction, which basically says that if an assumption leads to a contradiction, then that assumption must be false and its negation then is true. And that's the whole point. Remember, we negated what we're trying to prove. We showed that didn't work, so therefore the negation or the original proof statement must be true. That's the indirect way to prove something that is true. So this is the law of contradiction, and it's why it works. Okay, now we're going to actually walk through an indirect proof. We're going to do it algebraically, where it's a little more straightforward and easier to understand. Here is my given and my proof statement. It's given in a conditional statement. If x equals 4, then 3x plus 7 does not equal 22. So what I'm trying to prove is that 3x plus 7 does not equal 22, and I'm given that x equals 4, and that's a little awkward to try to prove directly. So what I'm going to do is I'm going to prove this indirectly. Look at what my conclusion is. What am I trying to prove? I'm going to negate that. So what I'm trying to prove is that 3x plus 7 does not equal 22. The opposite of that is that 3x plus 7 does equal 22. That's what I'm going to temporarily assume. So that's my step one. I took the conclusion or the proof statement, either one, and I negated it. So I'm temporarily assuming 3x plus 7 does equal 22. And now I'm going to walk through that algebraically. If that's the case, then 3x would equal 15. I got to that through the addition property. I added -7 to both sides. Now I'm going to multiply both sides by 1/3 and find that x equals 5. Okay, so I walked through that and I got x equals 5. Step 1 was the assumption. Step 2 was logically go through that until you reach a contradiction. Why is that a contradiction? Because what was our given? Our given is x equals 4. It does not equal 5. So this is the contradiction that I said you would run into. So let me show you how you could write that. Okay, so step 3 is to show the contradiction and therefore indirectly prove what I was trying to prove. But x equals 4, because that was given, therefore, that's our therefore symbol, 3x plus 7 does not equal 22, because if it equaled 22, there was a big contradiction. So that is the law of contradiction. And I have proved it indirectly. That's how an indirect proof works. Okay, just to conclude this video for today, I want to walk through one of your homework problems. The directions for this homework problem say to only state the initial assumption, because that's enough in itself. But I'm going to take it a little bit further. Because it's so much like the example we just did, we're going to walk through all the steps so that you can see how it ends up. But the question is, what is the initial assumption, the step 1? Here's my statement. If y equals 27, then 3y equals 81. What would you temporarily assume? So that's pretty easy. If we're trying to show that 3y equals 81, we're going to temporarily assume the opposite, that 3y does not equal 81. All right, so then I'm going to take it a step further. Let's follow through with that. If 3y does not equal 81, then dividing both sides by 3, y does not equal 27. That's the multiplication property. Okay, good so far, except, whoa, that contradicts the given. But y does equal 27, that's given. Therefore, 3y does equal 81. And that's the law of contradiction. I'm just going to put LOC, law of contradiction. So that gives you an idea of how these work. Hopefully this helps. We're going to spend some more time tomorrow or on the next video with a little more complicated ones so that we're just easing into it today.